Hi guys, this is another episode. We'll be continuing from where we stopped last time. So I said I'll prove the equations of motion. So in this video, I'll explain to you the equations of motion. So we'll be proving everything there are four, and we'll prove everything. I'll show you how we derive everything, and you know the basic four equations of motion. They are also called SUVAT equations. So we have SUVAT equations. Now, why are they called SUVAT equations? It's because they relate S. Now, what is our S? S is displacement. The U is our initial velocity. V, final velocity. The A is the acceleration. So A, acceleration. And then finally, the T is the time. The time taking. So basically, the SUV equations, the equations of motion, they relate displacement, initial velocity, final velocity, acceleration, and time. So I'll firstly start the four equations of motion, then we proceed to the proving of the four equations. So the first one is V equals U plus AT. That's the first one. The second one is S equals UT plus 1 over 2 AT squared. The third one is V squared equals U squared plus 2AS. And the fourth one is S equals U plus V over 2 multiplied by T. So to prove it now, we'll start from the first one. So equations of motion. Equations of motion. So the first one now. So how do you come about this first equation of motion? Now we know that our acceleration is change in velocity per time. So what is change in velocity? Change in velocity is the final minus initial divided by t. So now if we have A equals V minus U over t, and we cross multiply this, we have AT equals V minus U. If you bring the U to the side, it becomes positive. So we have U plus AT equals V, which is basically V equals U plus AT. First equation proved. Now to the next one now. S equals UT plus half AT squared. How do we come about this second equation of motion? Now basically what we do to get the second equation of motion is we substitute this first equation. We substitute V equals U plus AT into S into right here S equals U plus V over 2 times T, which is basically displacement is average velocity times time. So we substitute V equals U plus AT into it. So wherever we see V, we'll put U plus AT. So we have S equals U plus AT, then all over 2 times T. Now, if we expand that, we have U plus AT over 2 times T. So collecting items, 2U plus AT over 2 times T. So going further now, we have S equals, if the T multiplies everything in brackets, we have 2UT plus AT squared over 2, which is, now looking at this now, I want to break it down further. These two, we'll cut this 2. So we have something like 2UT over 2 plus AT squared over 2. Now, to cancel 2, which basically leaves us with S equals UT plus half a t squared. So we have just proved the second equation of motion. Now we'll be moving on to the third equation of motion, v squared equals. So we'll prove that also. Yeah. Now third equation. So how do we come about the third equation of motion? Still from our v equals u plus 80, v equals u plus 80, we make t the subject of the formula first. How do we do that? We bring the u to the other side. We have v minus u equals 80. We're making t the subject of the formula. We have t equals v minus u over a. You understand now? We made t the subject of the formula from this. Now we'll now substitute this. So let's just call this star. So let's say substitute equation star into. So we'll be substituting this into our second equation. Now we just go there. So into second equation of motion. Now that will basically now be, now second equation is s equals u. So our t now will now be v minus u over a plus half a dt now v minus u over a squared. That's how we did now. We substituted this into the second equation of motion with s equals vt plus. So now we'll expand this. We'll have s equals, if you open this, we have uv minus u squared over a plus a over 2 times, if you expand the top, we'll have v squared minus 2uv plus u squared. The square affects the top and the bottom, so it will be over a squared. This is v. Always make sure that you understand the distinction between v and u. V is the final velocity and u is the initial velocity. So don't make that mistake of interchanging. Now simplifying this, we have uv minus u squared over a plus, so this a multiply everything on top, we have a v squared minus 2auv plus au squared all over 2a squared. Now what's the LCM here? Our LCM is 2a squared. Now 2a squared a, that will be 2a times, that will be 2a times uv minus u squared, uv minus u squared plus, so this one, so that's a v squared minus 2auv plus au squared. So we'll simplify this further. That will be s equals 2auv minus 2au squared plus av squared minus 2auv, this is u, plus au squared, everything divided by 2a squared. Now if you collect like terms, which ones are similar? We have plus 2auv minus 2auv, so this one goes. Now we also have minus 2au squared plus au squared. So in the end, we have s equals av squared minus au squared all over 2a squared. Okay, let me rub off this part. Okay, so from here now, we can bring a out and cancel it out. So we have s equals, if we bring a out, we have a into v squared minus u squared all over 2a squared, 2a squared. So they cancel it, we have one a left. So our s equals v squared minus u squared over 2a. And if we cross multiply, we have 2as equals v squared minus u squared. So from here now, if we make v squared the subject of the formula, we have this u squared comes over here, we have u squared plus 2as equals v squared, which is basically v squared equals u squared plus 2as. So I've seen how we derive the first, the second, and the third. So now we'll move on to the fourth. So for the fourth now, displacement equals average velocity times time. Now what is average velocity? Average velocity is basically our u plus v over 2. So substituting it to this place, we have s equals u plus v over 2 times t. So this is the fourth and the last equation of motion. So we have successfully proven the 4 equations of motion. These are very important equations that you need to know, you to have at your fingertips. So we've done the proof. Now if peradventure you are asked, can you prove the equation of motion? After you watch the video, I'm sure you can confidently take your pen out and pen it down and prove it to anybody, and just make sure you are able to know the 4 equations, the basic 4 equations of motion, because they are very helpful. They're like the fundamentals of equations of motion in physics. So they are things that you must know. So I hope this video has been helpful. So we'll drop more videos. We'll drop videos on graphs, the displacement time graph, velocity time graphs of motion, and then we'll also drop some questions on motion, simple, complex questions, everything. So see you guys in the next video. Thank you.